We have this cylinder which is kept inside a circular surface. So initially the cylinder is at the bottom. So when you displace it a little bit, we need to find what will be the time period of these oscillations. So let's do it by the balancing the energies at extreme and at mean position. So for that we need to move the cylinder first. So let's say we move it by distance A. So the center of the cylinder, let's say we roll it and it moves by distance A. So let's displace the cylinder by A and release angle turn B theta. So let's say the center of mass makes an angle theta at extreme, and velocity of center of mass when it returns to mean position be V naught. So when it is released from here and when it crosses the mean position, let's say its velocity is V naught, and of course it will be rolling also. So let's write E extreme is equal to E mean. So because it has moved up, and how much distance it has moved up, so this distance is capital R minus small r, and up to here the distance is r minus r cos theta. So the height gained by the center of mass is r minus r 1 minus cos theta. So extreme energy, we only have potential energy, so we'll write it like this, is equal to energy at mean. So energy at mean is only kinetic energy, which is half ICM omega square plus half m VCM square. Now since it is rolling, omega will be V naught by r. ICM for the cylinder is mr square by 2. And 1 minus cos theta we can write as 2 sine square theta by 2. So we simplify that and we get this term of r minus r into theta. Now let us introduce amplitude, because in SHM we are more comfortable when we are dealing with amplitude in the in the linear fashion and not in the angular amplitude. So our linear amplitude is A, so let's introduce that. So A is r minus r theta. So we put r minus r theta as A and we get the relation between V naught and A. So now we can compare it with V max is equal to omega A for an SHM. So A is the amplitude and V is the velocity at mean, and that's what we have here. So we can, comparing these two, we can directly say omega is root 2g by 3 r minus r.